We know that glutathione is essential for the maintenance of long-term good health, and the body's ability to continue to make it is critical. But there are things that challenge that and cause glutathione levels to be depleted. What are some of those things?
So you can get glutathione depletion either through two mechanisms. First, acutely, so that's exposure to toxins. So, for example, acetaminophen. So
Tylenol, right?
So, Tylenol.
One of the most common forms of suicide in the United States.
That's right, and that's right. And you don't have to take a lot of it. Interestingly, we don't call it acetaminophen in Australia. We call it paracetamol. Anyway, that's by the by. But what it does is it depletes the glutathione in your liver, particularly, and acutely. And there's 3 amino acids that constitute glutathione, and the first one that runs out is cysteine. And so if you present at a hospital in an emergency after having taken too much acetaminophen or Tylenol, then they're going to treat you by providing you with cysteine in the form of N-acetylcysteine.
A toxic insult.
That's a toxic insult, and that's the most common one, is acetaminophen overdose. But then there's chronic depletion, which is associated with a whole myriad, any disease you think. Think of, from the neurodegenerative ones such as Alzheimer's and Parkinson's to even diabetes, you name it, whatever disease it is, then there's going to be an association with glutathione depletion. In many of these conditions, it's related to something becoming dysfunctional in how glutathione is synthesized inside our cells. The first enzyme that converts cysteine and glutamate into GGC, gamma-glutamyl cysteine, becomes dysfunctional, and the homeostatic level is lowered. And by that, we mean that there's not enough glutathione being produced inside that cell to mop up all the free radicals or address any exposure to toxins.
How about endurance athletes who go out and run marathons?
So in that situation, you're looking at, it's very similar to the acute overdose with acetaminophen. So you're doing this excessive exercise, which means you have to generate a lot of energy to be able to do that. So your mitochondria are working overtime, producing all of this ATP to drive cellular function, and at the same time you're increasing the rate of free radicals, which means you need to pick up the pace on producing glutathione and recycling it. The glutathione has to be recycled, and that's another enzymic process. And if you outpace that, then the cells are going to be left in a condition of oxidative stress, and then you're going to get damage. And if you can repetitively do this, then some of that damage is not repaired immediately. It can become accumulated.
So we've talked for a while now about the process, which I now understand is cysteine and glutamate come together as a result of GCL, and then it's a pretty much a free path to glutathione. If someone has an acute depletion of glutathione, maybe because of a toxic insult, or maybe because they've gone out and they've run a marathon or something like that, and they are given cysteine, because that maybe is a limiting factor. That cysteine still has to, whether it be in the liver or any other cell, still has to be put together with glutamate and then added to glycine to make glutathione.
That's right.
Is that right?
Yeah.
So if the cysteine is a limiting factor, then we would hope that in a toxic situation, that raising the level of cysteine that's available would then facilitate the rapid production of glutathione. But that still requires that the GCL enzyme be highly functional or fully functional.
Exactly. So there may be some benefit, and before you're embarking on really strenuous exercise, to make sure your cysteine levels, through dietary supplement in food or through a supplement itself such as NAC, may be of benefit to making sure you got everything you need to build glutathione, but it still may not be sufficient to depending on how the level of exercise that you undertake, to mitigate the oxidative stress.
So is it possible, and obviously research would have to look at this, that if we bypass that ligase, that GCL, and consume gamma-glutamyl-cysteine, which is what comes after that has worked, that could be an even better way of ensuring glutathione levels?
Well, it's research we're planning at the moment is to investigate the potential for gamma-glutamyl-cysteine to increase glutathione levels before exercise, and then we will take measures over time after that exercise to see whether there's been any benefit in the oxidative stress and recovery from exercise.
You've got some exciting times.
It is. We're collaborating with lots of partners around the world to look into all various diseases, conditions, both in chronic and in acute depletion of glutathione.